Good afternoon, morning, wherever it may be for you folks. Hey, Mr. Mullett here. It is day 7, or sorry, January 7th. Good Lord, clearly a little tired. Recording live down from the dungeon of the Mullett farmhouse. It's January 7th and I'm recording this, but to be fair, it's just better off if you refer to this as day 4 of the lectures while I'm out. Today will be the last day of lectures prior to your vocabulary quiz and your sea layer being due. But before we get into all that, I want to make sure I cover the basics of where I am these days. Alright, so this is me scrubbing in. On last Tuesday, obviously, I mentioned that we have a newborn in our world, and I wanted to kind of let you know about Mr. Milo. Milo was born at 4:50 on Tuesday, doing really well, happy, healthy, sleeps frickin' all the time, good Lord. But he's doing really, really well. This is him a couple hours after, and this is him engaged or enjoying the burrito wrap, as we call it. This is his older brother Everett, who is very, very excited to have a younger brother. Super, super excited. And yeah, so there's the little tykes at this point, folks. But yeah, Milo's doing really, really well. And yeah, so anyhow, let's get back to today's lesson. Alright, so let's see here. Mr. Mullett's going to reinforce this for me. I appreciate that. We do want to remind everyone that your vocabulary quiz, for the most part, is going to be Tuesday, being tomorrow, and that being January 12th. If your class doesn't meet on Tuesday, guess what? You get on the 13th. But I want to make sure that everyone has seen video 4 prior to the vocab quiz, and it should be noted that your sea layer is definitively going to be due on the Wednesday, and that's basically just, look, you've had plenty of time to do this, and so you need to get it done. All the topics in the sea layer will be covered by the close of this lecture, number 4, and at which point it's up to you. Just get it done at home, get it done in class, after school, tree period, whatever you got going on, get it done, borrow a book. Please complete your work and be ready for everyone to have their sea layer corrected on Wednesday. The completion of your sea layer being corrected will allow you to work on your concept layer check-in. So that's another open worksheet quiz you can take once you've corrected your sea layer, and then you can be working on your interviews between today and Friday to try and get that done as best as you can. If you need to push your interview to after the Martin Luther King holiday, that's fine, but your concept layer check-in really should be done by Friday if your sea layer is corrected by Wednesday. That makes sense to me. Alright, so anyhow, I do know that at the end of the week there's going to be a couple of documentaries Mr. Mullett's going to show, so if we have to finagle things with the concept layer check-in and the interview to the following week, fine, so be it. But if you're ready to go and you're one of those students who want to get things done, by all means, let's make it happen. Alright, so I don't like this agenda at all. Let's get out of here. What is going on? This is the agenda we want. So the fronts and air masses, got a quick little YouTube video I'd like you to watch. It's a nice little demo about warm and cold air masses and how they interact. It's a really, really kind of nice visual, and that'll move you into the condensation nuclei video. Those two videos actually pertain to Fiji waters, and one of the cool little experiments you can do with Fiji water, which is really kind of nice to see. But at any rate, understand that precipitation, rain, sleet, hail, snow, none of that can exist without something for the precipitation to condense upon, hence the term condensation nuclei. So things condensing on an object in the middle, hey cells, hey atoms, nucleus, nuclei, middle. So you'll get a chance to see that when you watch these videos. It's pretty cool stuff. Also going to talk about local winds for land and sea breezes, as well as the global winds, and then talk about the Coriolis effect, and then finish up with the 2 topics of Earth's energy budget and global warming climate change. This may be 2 videos, we'll see, but let's get rolling. Alright, so obviously I just jumped over here. There's the fronts and air masses video. I'd like you to watch that. Let's see here, the Fiji water. There's 2 video clips here. It'd be nice to get you to see both of those. Pretty interesting stuff. A little bit of a trick and a little bit of magic, if you will, but definitely talking about condensation nuclei. Alright, so here we go. There's going to be a bigger, better picture to show in a moment, but I would ask that you get your notebooks out and you collect this information. I'll go and highlight the necessary areas. So, Mr. Highlighter, there we go. Alrighty, so local wind, this being sea, and land breezes, the topic of that being wind. So, you know, definition-wise, wind is any type of air that's moving along Earth's surface. Let's learn about how the wind occurs. Here we go. So, if it is a point of importance here, it should be noted that land will always heat and cool faster than water. All right, the land warms up, the land cools down just so much faster than the water. Think about when you go to the beach. If you go to the beach early in the morning, the sand feels cool. By midday, the sand could be painful, or you have to bury your feet down under the sand so that you can survive walking back to the car. And just that experience doesn't happen with water. Sorry about that. Small emergency upstairs. We're all good. I think what I was saying, and I do apologize, I think what I was talking about was that the land will always heat up and cool down faster than the water. So, like I said before, sand could be cold, could warm nice and fast in the day, and cool down again at night, yet the temperature of the ocean may not vary all that much in the course of a day just because of something called specific heat capacity, which I won't get into. Just understand that land always warms and cools faster than the water. Depending upon the day or night, moving air will come from the land or the water, and it's always from high to low. So pause the video, let you get this in to your notes, and then we'll have you draw the picture in a moment. Pause video. Alright, thanks for pausing. Okay, so you got this part, and let's go with the next bit here. Big old picture here to help with the understanding. So this might make sense to have a drawing in your notes supporting sea breeze and land breeze. First things first, let's point out the name of the situation is based upon where the wind comes from. And that's actually how it's done in all meteorology. If we're talking about a westerly wind, we're talking about a wind coming from the west. If it's a nor'easter, hey, guess where it's coming from? It's coming out of the northeast. So that just happens to be how things play out. But please, to your notes, it would make sense for you to draw both situations, knowing that you can see in the sea breeze, you have the land, which we said warms up first and warms up fastest. And so if we absolutely had to do some numbering here, I would indicate this as part 1, at which point that warming air rises because it's less dense. The air needs to come in and take its place, and so it does. So this movement here is 2. And obviously, as I said before, from high to low, so if the pressure is changing, so now we've got this high pressure that's being drawn across from the sea to the land. This is now a low pressure, and that makes this a high pressure, and so the air falls. So there's number 3, and there's number 4, and you've just got basically all 5 situations right here, and that is what we call a sea breeze. So please draw a sea breeze with this type of pattern, with this type of air movement, and do the exact same thing for a land breeze. And if I had to go and start again, at nighttime, the land is cooled down greatly, so the air above it's nice and cool, but the water might actually be warmer than the land, and so the air above the water will be warmed and it'll rise. So this is going to be number 1, and to take its place will be the air from the land, so that's number 2 here, number 2 if you will. And let's get rid of this. This will become number 3. This will be number 4. And this will be number 5. And again, slightly different than the sea breeze in the direction here. But again, please remember, it's where the wind comes from. If it comes from the land, it's coming from the land. If it comes from the sea, it's called a sea breeze. So let's get this into our notes. And if you absolutely need to, we can go and bring back the slightly nicer picture. But I would pause and get this into my notes, please. Alright, done with the notes. Alright, so there are 2 different breezes, local breezes we call it. And now moves us into something called the Hadley cells. There's a little YouTube video at the bottom here you could definitely watch. It's nice to help see a better sense of what's going on. But the Hadley cells are what we call global winds. So local winds for the sea and the land breeze, this is called a global wind. Wind that spans a greater landmass or ocean area, if you will. So let's get to our notes here. We have Hadley cells, they're called. And we're going to refer to them as global winds. Alright, so these global winds, what's going on here? Well, due to direct light at the equator, air is heated and rises. We're going to refer to that as the doldrums. That's kind of where the majority of the winds start, at the equator. We're going to call the air that takes its place is called the trade winds. You may have heard of the trade winds. My brother would probably comment. There's a store at the Orleans Rotary called the Orleans Trade Winds. A store filled with crap more than anything. Decent saltwater taffy, but mostly crap. And last but not least here, the rising and falling air separates the winds. And so I'll show you this in a moment here, but basically, if I was to look at the equator, most of my direct light is hitting this area right here. And so this air, air above the water is heated first, and so that rises. And you get this rising convection going on right here. Convection we've talked about before. And obviously cooler air is going to take its place, and so the cooler air rushes in. And that cooler air rushing in is called the trade winds, as mentioned in the notes. And ironically enough, that happens at the next point there, that being the 30th degree parallel right there. That 30, we actually have air falling, and so falling air would predicate a rising at another point. So at the polar easterlies, we have rising, and we also have the westerlies coming across the United States. And it should be important to note here, folks, that this whole movement of air across the United States, I hope most of you noticed that our weather comes from the west and goes to the east. If you haven't noticed that, what the heck have you been watching and or paying attention to? But all of our wind does come from west to east, and so that's powered and pushed by these westerlies. A nice way to view this. So go ahead, pause the video, grab your highlighted notes from the, well, that side of the screen, and I got a little image to help you with this. Alright, so we're done with our note taking. Let's go and get this image in here. Could you please? It's a really, really bad drawing, but ladies and gentlemen, could you please draw the northern hemisphere? Alright. And go ahead and draw in these three parallels. We also need to do a little more drawing here. I'm going to put a person at the top of the earth, which we don't always have, but I'm going to put someone up here. And there's it for it. I'm going to ask you that you draw a scooter, or one of those razor blades, if that's your thing, scooter there. And if you'd be kind enough to draw a bus right here. Yeah, I'm sure you all are better drawers than I. Illustrators, if you will. But let's get a bus with some windows. The windows are kind of actually important. And don't forget the wheels. Alright, so we've got a bus being drawn, and next up, to the best of your ability, you could draw really like a fast sports car, I guess is what I'm trying to draw right here, and it's really not coming out all that good. But the case in point being that this car is faster than the bus, which is faster than the scooter, which is faster than the human standing at the top. And here's what I want you to see. We're students, we're teachers, we're associated with the school, let's be on the bus. Now, you probably could imagine a couple of key characters on our team if we're on a field trip going somewhere that somebody might want to throw something out of the window and try and hit a car. Let's say that somebody was upset with the speeding car, the fast zip car at the bottom here. And so someone said, you know what, I'm going to throw my gum at that fast car. Now, obviously if you play football or baseball or any sport where there's throwing or kicking, you sometimes know that you need to lead your pass. Well, this